All right, thanks. So exactly the topic as described is what we're going to be going into today, talking about MySQL on infrastructure as a service for mission critical cloud applications and multi-cloud strategies. It's no surprise to anyone, there's lots of different options for running MySQL in the cloud. One marvelous way of doing it is running MySQL on Kubernetes. And in conjunction with the MySQL operator, one of my colleagues describes it as a near PaaS experience, which sadly, because of the lack of time, we're not going to have a chance to talk about. Another way to run MySQL in the cloud is through HeatWave. We've had many sessions over the last 2 days on the HeatWave topic, and so we will consider that one to be well covered as well. Number 3, MySQL on infrastructure as a service is going to be the highlight of the discussion here. And my aim is to give you 3 things that you can consider for your applications and organizations to know whether MySQL on IaaS could be the right solution. And along the way, we're also going to compare and contrast this with database as a service, specifically database as a service as provided by Amazon, Microsoft, and Google. And at the end, we'll recap with kind of 2 interesting technical realities that not everyone is necessarily fully aware or considered about running MySQL on IaaS. So the 3 considerations that we're going to take a look at are driven by my own customer experiences. So I've had the wonderful opportunity to be with the MySQL sales consulting organization for the last 17 years. As time has gone on, more and more of those conversations have a cloud element or are a cloud discussion. This is everything from little fintechs that are now bigger fintechs that were born in the cloud to financial services and healthcare companies that are listed on the Fortune 500 and various exchanges. And it's based on these customer experiences that I'm powering the content of my presentation today. These are not my ideas, rather they're a distillation of the things that I've learned from my customers who have had cloud experiences that have gone smoothly, as well as some cloud experiences that have not gone smoothly. So the 3 things we're going to take a look at that can be good indications about where it is that you should be running your MySQL applications in the cloud is going to be the scale of the applications, the importance of the applications, and also the nature of the multi-cloud strategy your organization has. And I would say that all of these exist on something of a continuum. When we take a look at scale, we can have bigger workloads or smaller workloads. And we'll kind of go into some details why many of the bigger workloads will actually run better on MySQL on IaaS. In terms of the criticality of applications, we can have things that nobody cares about, we can have things that departments care about, and we can have things that the CEO cares about. As the importance skews up, we've got a better case for MySQL and IaaS. And rather self-evidently, as your cloud strategy moves towards multi-cloud and hybrid being the direction for your organization, it's another indication that MySQL on IaaS could be the right choice for you. And when we talk about MySQL, in today's discussion, we're going to be specifically talking about MySQL Enterprise Edition. For those who are not familiar, there's a number of differences that Enterprise Edition has in terms of functional advantages compared to the Community Edition, many of which are going to be relevant during the course of today's chat. And these include MySQL technical and engineering support, a range of advanced tools, database enhancements specifically related to security and performance, and also things that we've built into MySQL Enterprise Edition that specifically make it very good in a multi-cloud situation. So scaling databases in the cloud. If we start with MySQL database as a service, say you're running a 8 or 16 vCPU system, and you go, this is pretty wonderful, I can keep turning the knob up, I can get better and better performance. My cloud vendor, I can get up to 64 or 128 vCPUs, and life is good. Life can be good, but also life can potentially reach a screeching halt before you scale up to those largest of boxes. And the hidden challenge that a lot of organizations have not well tested for is challenges around IOPS, around input-output operations, because of course all databases are very disk-centric. And as your volumes continue to increase, your demands on disk continue to increase. And you go, well, that's wonderful, because I can scale up potentially in a number of ways, right? So Depending on the cloud vendor and how things are organized, we usually have ideas of I can get better overall bandwidth by increasing the size of my DBAS box. I can increase IOPS by either increasing the size of the storage array or be specifically purchasing them from things like reserved IOPS. The problem is those IOPS numbers are for the entire storage device. So if you have X number of IOPS, that X number is scattered across the 500 gigabytes or entire terabyte of storage that you've allocated. So if you're evenly using all of that disk space, then you get all of those IOPS. If you're not, and most highly transactional workloads, especially those that haven't been enormously well thought through, can have very specific hotspots. So as you continue to throw more and more and more IOPS at a relatively small area that's under contention, you can run out of steam. And at that point, you don't have a scaling option as native to that DBAS solution anymore. Well, the good news is the cloud vendors have anticipated this and they have solutions for you. And they're named with pretty handy things. One of them rhymes with hammer. In the end, they offer a higher scaling experience than what you've had with your DBAS solution. However, there are consequences to shifting to these architectures. One of which is you're going to have to provide some kind of re-architectural experience, go through some kind of re-architectural process. Pricing is going to likely be less pleasant than it was earlier on. And also, you've very much locked yourself into that particular cloud vendor's specialty cloud-native DBAS service. How do things look on the IaaS side? Well, we're going to start likely on the same style of hardware that you are running your DBAS solutions on. Some type of IaaS box with some network-attached block storage. Ultimately, Enterprise Edition is going to get you further down the road because of a number of reasons. One, we've got performance enhancements baked into Enterprise that aren't available in the Community Edition that the DBASs are based off of. You also have access to all of the possible tuning parameters in MySQL, and you will also have access to our organization to help you turn the knobs to make sure that you're getting the maximum possible performance out of those boxes. So along the way, it's great because you can potentially run on smaller hardware to be able to save costs, and ultimately your upper end of performance is going to be higher. But what happens when you run out of steam? All of the cloud vendors, in the case of Oracle, we have got a wonderful range of shapes we refer to as dense I/O. In the case of Amazon, I think they're called something like storage optimized. And these are IaaS boxes that have marvelously fast NVMe storage attached to it. So it's a very simple lateral move of changing the nature of your shape from one that's using block storage to using NVMe. We get rid of those I/O scaling problems, and we have a much higher upper level limit of performance than we had with running conventional block storage. So we're able to get much further down the road. And what happens if you inevitably, potentially, I guess, run out of performance here? There is a MySQL variant referred to as NDB or MySQL Cluster Grade Edition with automatic sharding up to 255 nodes with absolutely incredible upper levels of performance. So as you take a look at scaling, this is what kind of tips the favor often in the direction of MySQL on IaaS. You can start simply, you can get some very advanced hardware, and then you can get some even more advanced variants of MySQL for very high upper level limits of performance. So that's the first of the things we were talking about is scale. Next one we're going to talk about is the importance of the application. Is this something that the CEO cares about or not? And as we talk about importance, unless you've got a full database team where you are completely self-sufficient for MySQL on your own, you're going to be looking to someone else for supportability. What happens when the database itself has a problem? And I'd like for you to consider support as something a little bit more complicated and nuanced of whether I have support or not. The question isn't whether you have support or not. The question is do you have support that meets the expectations that your organization has for the nature of the application that's running in this solution? And so for the sake of simplicity, we're going to break up support into kind of three categories here. Can a support organization handle basic questions? How do I change a parameter in MySQL? More complex things, like I'm running a very heavy OLTP workload. Periodically, my application performance is completely stalling out. I've gone through all the usual steps, but I can't figure out why things are slowing down periodically. And at the highest level, I've run into some type of availability, performance, or security bug, which I need to get fixed to be able to have a path forward with MySQL. And one of the interesting ways I think we can ponder this supportability topic is to use a general purpose way of reasoning referred to as first principles. And so I pulled this quote off of the internet by someone who's a big advocate of first principles. First principles is a physics way of looking at the world. You boil things down to the most fundamental truths and say, what are we sure is true? And then reason up from there. So let's start with organizations that are running MySQL Enterprise Edition on IaaS, and they have a support relationship with us. What are fundamental truths that we know are true? Well, we know the MySQL organization here at Oracle, we employ the engineers who do the primary development of MySQL Community Edition and MySQL Enterprise Edition, certainly with enormous thanks to all the wonderful contributors that are out there in the MySQL community. MySQL here at Oracle, this is a fundamental truth. We do the regression testing and the packaging of MySQL. And it's a fundamental truth that we've got a business of now 30 years of supporting MySQL customers. So we recognize these as fundamental truths, and we can reason up from there. So is it natural or is it reasonable to think that this organization can answer basic MySQL questions? I think yes, certainly yes. How about complex troubleshooting? Based on first principles, can MySQL here at Oracle help you with complex troubleshooting? First principles would say yes. And how about if there's engineering and regression tests needed for your particular fix? First principle says yes. How do things look if you don't have that relationship with us and you're running one of those 3 DBaaS services? So based on first principles, what do we know is true? We know these organizations, they grab a hold of MySQL Community Edition, and they make some changes to it, and they package and they run it inside of their environment. These we know as fundamental truths. And if we reason up from there, we say, can these organizations likely help you if you have a basic MySQL question? First principles would say yes. If you are running into a complex MySQL issue, do we have anything in first principles that says that these organizations are going to be able to, at 2 o'clock in the morning on Black Friday, help you troubleshoot your OLTP workload? First principle says no. And do these organizations have the kind of people and the kind of resources required to be able to fix a bug and regression test it in MySQL? First principles would also say no. So there's ways to look at this alternatively, and I would say that could be either aspirational or potentially delusional. But in the end, first principles thinking is probably a safe place to start when it comes to if your application is really critical, if you don't have a crackerjack team of MySQL experts, you're going to be relying on a support team at some point. You want to make sure it's the right kind of support team. And then the third thing we're going to talk about is hybrid and multi-cloud strategies. So this comes from our friends at Cloud Zero. It looks like about 63% of organizations out there run some kind of hybrid or multi-cloud strategy. And it's important to note that you have to make your individual technical decisions to reflect your strategy. If my goal is weight loss, my individual eating decisions cannot be based around Taco Bell and Whataburger. I have to align my individual decisions to that of the strategy. So if we do have a hybrid or multi-cloud strategy, what are the attributes of the software, maybe specifically the databases that we should look at to make sure that the products that we're selecting reflect our hybrid or multi-cloud strategy? And I would say there's 4 things that you could look at in a technology to make sure that there is alignment. The ability to run anywhere, the ability to have an identical experience, being able to span workloads across environments, and also automation. And when we take a look at all 4 of these characteristics, we can examine how does MySQL Enterprise Edition running on IaaS meet up with these 4 hybrid multi-cloud values. So run anywhere. I want to be able to take the software and put it on any one of the major clouds, any one of the minor clouds. I want to be able to run this on-prem. MySQL Enterprise Edition on IaaS checks off that box. Identical experience. I want to be able to have the same range of configuration options, the same MySQL built-in capabilities, including how MySQL can handle high availability. That's the same regardless of where it is that I deploy my MySQL systems. Span workloads across environments. There can be a number of reasons why it makes sense to have a given application have some resources in one cloud and maybe other resources on-prem or yet in another cloud. One of those reasons is kind of an always spanning disaster recovery. I have all my eggs generally, instead of having all of my eggs in the basket of a given cloud provider, I can also employ a DR strategy in another cloud or on-prem. Or in the case of migrations, instead of trying to have some big bang difficult migration of needing to throw lots of switches near simultaneously, I want to be able to have my cluster span clouds or on-prem environments and easily be able to move my workloads between them. And that takes us to automation. So this is one of our lines in MySQL cluster sets. This gives us the ability to deploy multiple MySQL InnoDB clusters across various locations and lasso them all together with the thing that we call the MySQL cluster set. So let's suppose I have all of my operations on-prem. I then decide to deploy a cluster in OCI. I run one command in the MySQL shell, and all of my database operations and all of my application connections automatically switch over from on-prem to OCI. So this alleviates a great level of workload and also a great level of risk and potential disruption as you look at achieving that multi-cloud or hybrid strategy of being able to move workloads around or fail over as necessary. So this is another one of the areas where MySQL Enterprise Edition on IaaS really shines. So those were kind of the three considerations for whether a given workload or your organization would be well off looking at MySQL on IaaS. We're going to take a look at kind of two technical supporting elements that I think are useful to ponder. Unquestionably, an advantage that database as a service has is ease of use. People say, Benjamin, this is truly wonderful. I go into the console and I go click, 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 and I've got a MySQL database. And you're right, except you really aren't, because in the end, nobody goes into a console and deploys a MySQL production database. You write a Terraform script, right? Because you want to make sure it's particularly dialed in and it's repeatable. So you write a Terraform script once, and you execute that Terraform script every time you want your MySQL environment run. This is as easy as it gets. This is truly wonderful. But what does it look like running MySQL on IaaS? We're not as good as this, but we're surprisingly close. Because what would it take to provision a MySQL database on IaaS? Well, instead of writing one script to provision, we write two scripts to provision. We write a Terraform script that's going to build up my IaaS environment, and then we're going to call an Ansible script that we're going to run, Ansible or Puppet or Chef or whatever flavor it is that you particularly love, and that's going to install the MySQL system, configure it as appropriate, tie it into your availability and backup situations, and it's off and going. So in both cases, you're writing scripts. In the case of MySQL and IaaS, you write two scripts for fundamental operation, but in the end, you're simply executing a Terraform script every time you want that operation to take place. So the gap in terms of ease of use is not nearly as significant as you might think it is without having kind of pondered how these things are when they actually operate. So that's the first of the things that I wanted to point out. Second of the things I wanted to ponder, or to point out and have you consider is there's a vast range of services that are out there in the cloud that DBaaSes tie into. And one of the interesting things is, we hinted at this earlier, MySQL Enterprise Edition in particular has a range of hooks that allow us to tie in to these cloud native services. So our first example, because OCI is awesome, is going to be that on OCI. So OCI has marvelous things. It has the ability to manage your encryption keys. It has OpenID for authentication. It has an object store. And MySQL Enterprise Edition has the hooks to tie into these OCI services. So you can manage your own encryption keys by using the OCI key store. You can manage authentication by using OpenID, and you can push your backups to the very low-cost option of object store. And OCI isn't the only place where we've added these integrations. These same integrations exist for other cloud services. This is our example in the case of AWS. So AWS, I think they simply refer to it as the AWS key store. Our encryption, our transparent data encryption module ties into the AWS key store function. We can tie into OpenID again. And enterprise backup can specifically push encrypted backups up to S3. So yes, MySQL is on-premise software that you can run in the cloud, but it's also on-premise software that already has built into it many hooks to optimize its experience when you are running it into the cloud. And none of this stuff is theoretical. The number of customers who are running MySQL on IaaS is absolutely vast. When you hear many conversations about folks who are running MySQL in general, they're not always specific that they happen to be running it in the cloud. And if they are running it in the cloud, they're not always mentioning that they're running it on IaaS in particular. We've got a wonderful case study. The URL was entirely too long, so I created a little QR code that you'll have. It's Rapid, which is a fintech company that is using one of those three other clouds, and all the specific technical details are pointed out in this case study. Many of the things that we talked about explicitly earlier were things that Rapid ran into. They got going with a DBaaS managed service. At the beginning, hello world works in all application languages. All the DBaaS systems give you a great experience at the beginning, but over time, things didn't work out so well. I/O became a major bottleneck in terms of performance, and it was also something they were having to throw a huge number of dollars at to be able to keep up. Supportability problems. They were running into MySQL issues. They opened up support cases, and most of the time the response was kind of something in the order of, have you tried upgrading to the latest MySQL version or not? They didn't get much further than that with the cloud vendor. And they're very specific about the advantages they found by migrating. Everything is staying in that other cloud, but their MySQL system is moving from database has moved from database as a service to MySQL on IaaS. It's their DevOps director. He mentioned with MySQL Enterprise Edition, we boosted performance, enhanced security, and reduced cloud computing costs by 30%. This strategic move positions us for future growth and innovation, reinforcing our commitment to technical excellence and staying ahead in the competitive fintech landscape. So again, many interesting technical details are spelled out in the case study, and I encourage you, after you get a copy of the slides, to go visit the case study in detail. So ultimately, hopefully, this is an intro session. This is a potentially complicated discussion that we're trying to cram into 30 minutes here, but to give you three of the big things that you can look for in your workloads. As scale goes up, MySQL and IaaS can be advantageous. As the criticality of the application goes up, MySQL and IaaS can be the solution. And certainly as you look to deploy some kind of hybrid or multi-cloud solution, MySQL and IaaS, again, can be the compelling choice. If anybody has interest in furthering this conversation past the point of today, I would absolutely welcome it. If there's things that you'd like to add to my basis of knowledge and understanding of how things have worked inside of your organizations, I would be delighted. Drop me an email, benjamin.wood@oracle.com. I would be happy to continue the conversation. I certainly appreciate everybody attending the conference and specifically taking the time to attend my session. I'd like to say, open source for life, Sequila forever, and thank you all very much.